Now a methyl group is now another new chemical group. You haven't had a new one in about a day, so it's time. That's a methyl group. CH3 is coming from a larger molecule, methane. Methane is natural gas. So as usual, that's negative sign here just means open bond. Now what it really means is there's only 3 hydrogens, but actual methane has 4. So it's missing a bond. It needs something. By the way, this YL suffix, we've seen hydroxyl, we've seen carboxyl, we've seen some other things, and now methyl. The YL ending means an open bond. Like the difference between methane and methyl. The methyl means there's an open bond here. Methane means you just got a molecule. For the YL, like again, hydroxyl, carboxyl, you've got an open bond. It's an indicator. So, during the period of adaptation, certain membrane proteins become methylated. They receive methyl groups. These proteins are MCP proteins, methyl chemotactic proteins. That's what the MCP is. Methyl chemotactic proteins. And I know that doesn't tell you anything yet, but these are proteins in the cell membrane. And they are going to receive methyl groups. Now bear with me because it's going to get tricky now. So again, if something's not clear, please do ask. It's not in the book. So what you see is what you get. Now, anytime you're adding anything, it takes enzymes. So, in the presence of an attractant, you're getting methylation, you're adding a methyl group to the MCP. And the enzyme here is methyltransferase. So, with an attractant, methyltransferase will pick up a methyl group and move it over to the MCP. Yeah, in the presence of an attractant, methyltransferase picks up a methyl group and moves it over to MCP. I can tell by the looks on most of your faces that's not very clear. Bear with me just for a second. Bear with me just for a second. This will be one of those times when if I continue, it might become more clear. First off, the methyl group there, that's your CH3. Come from somewhere. It doesn't appear by magic. So it's going to come from S-adenosyl methionine. That may not sound very helpful to you, but again, bear with me. First off, the methionine is an amino acid. The methionine is an amino acid. Remember, there are 20 amino acids in nature. This is one of them. You find amino acids in proteins. So this methionine is part of the MCP protein. It's a different part, but it's still part of the protein in the membrane. The S there is sulfur. Honestly, big deal, but it's there, sulfur. That adenosyl, now there's that YL ending again. That means open bond. In fact, adenosyl, the standalone molecule is adenine. And you're all familiar with adenine. You may not know it. We haven't talked about it. But from other classes, for example, ATP, adenine triphosphate. Or if you remember your DNA from other classes, adenine is one of the 4 bases. Adenine, guanine, cytosine, thymine. So you have seen adenine before somewhere else. So it is a standalone molecule as adenine, but if you take off a hydrogen, it needs to bond to something. It becomes adenosyl. So basically, the adenosyl is adenine bonded to methionine, and then the S. So I'm going to call it just SAM, S-adenosylmethionine. SAM is okay as far as I'm concerned. So here's how it works. The methyl group is coming from SAM. We're taking a methyl group. Now notice here I didn't put in that minus CH3 that I've been doing all quarter. But in this case, it does not mean open bond. In this case, I mean it that we are losing the methyl group. It's being removed from the SAM. That's what the minus sign is. We are taking this away. It's being brought over here, and it's added to the MCP. The enzyme that does this is methyltransferase. So in the presence of an attractant, the methyl group is removed from SAM and is brought by transferase. Transferase alone is okay. Transferase over to MCP. So the presence of an attractant, the methyl group is removed from SAM and added to the MCP. That's the methylation. Yeah. The methylation is adding the methyl group to the MCP in the presence of an attractant.
And this is happening on the membrane of the bacteria?
Yes, because the MCP, the methyl chemotactic protein, is in the cell membrane.
Say that again?
The MCP, the methyl chemotactic protein, is in the membrane of the bacteria. Now, in the presence of a repellent, we get demethylation. That means removal of the methyl group from the MCP. And it will go back where it came from, to the SAM. So now, with a repellent, removal of the methyl group from MCP, and addition back to the SAM. It goes back where it came from.
And that's by the same enzyme?
No. In fact, just what I got up there, a different enzyme, methyl esterase. So what we can say now is in the presence of an attractant, methyltransferase is what is active. In the presence of a repellent, methyl esterase is active. Depends on what stimulus you have. That determines what enzyme you get. Now, whichever enzyme you get, you're going to be getting methylation or demethylation.
So for demethylation or does methylation occur?
No, good question, good question. Her question is, do you need to have had methylation first before you can demethylate? No, as a matter of fact. So what that means is there are already some methyl groups present in the membrane before we do anything. Because otherwise, what she suggested would be absolutely correct. You couldn't really demethylate before you had an attractant. But in fact, there are some methyl groups already there before you start.
So where's these methyls, the enzymes and everything, where's it coming from?
Oh, it's in the cell. I mean, these enzymes and many others are already in the cell. So the fact that you have an attractant, that would activate your transferase. Or the fact that you have a repellent would activate your esterase.
Is this the flagellum that's doing that, or the?
No, the flagella is part of the bacteria. The enzyme is coming from elsewhere. The enzyme is coming from the cell itself.
Bacterial cell.
Mm-hmm. Mm-hmm.
So
Yes.
methylation and demethylation
Before the flagellum,
all happening.
it even started taking the track. I thought the flagellum came before.
Go ahead. You still look uncertain.
Yeah, because I thought the flagellum was the reacted.
It's going to, yes.
But then the
No, I'm just saying the enzyme is coming from somewhere else. It will go to the cell membrane.
so the cell itself recognizes the repellent
Yes.
before the flagellum reacts to it.
No.
Or she's saying that the
No,
flagella
the
reacts and
flagella
then
is
this
going to
occurs.
react. I see where you're, yeah. Let's put it this way. The bacteria is going to receive the methyl group. The methylation is going to activate the flagella. So what you're kind of saying is, yes, the bacteria is going to recognize the attractant before the flagella does, but the bacteria is not going to do anything about it.
Yeah.
Yeah,
It's the
it's
part
the
of it that does
flagella that will
something.
respond. But the chemical action is going on in the bacterial cell membrane.
Okay, because the flagellum is the part of the bacteria that can actually move.
Yes, exactly right, yes, yes.
How does methylating?
I'm sorry.
How does
You're on hold again. You're asking great questions, I just don't want to answer them.
Like,
Her question,
what's the point?
Wait.
it's coming, it's coming, it's coming. Her question is, what exact effect does the methylation have on the cell membrane? And I don't want to answer it yet. So once again, you're on hold, but I will answer the question. I'm hoping tonight, So I want to get through this chemotaxis tonight, even though you're being kind of drowned right now. I do expect to repeat this on Wednesday, or Thursday, to give you a second.
Tuesday? Oh, no, Thursday. Sorry, Thursday. No.
So, anyhow, look, I want to get to her question because it's a great question. I'm just not ready for it yet. So let me again summarize what I've got here. In the presence of an attractant, the methyltransferase is going to become active. It will pick up a methyl group from SAM in the cell membrane, in the protein, in the cell membrane. The methyl group will be carried by the transferase, transferring over to the MCP, to a different location in the MCP, and will drop off the methyl group. In the presence of a repellent, esterase becomes active. It will pick up a methyl group from the MCP, from this location, and will take it back where it came from in the SAM. So, attractant causes methylation, repellent causes demethylation. Adding and removing methyl groups.
Moving around the proteins within the bacteria. So
Yes, yes,
Just in the cell,
in the cell membrane,
cell membrane.
yes.
So methylation happens in the membrane of the bacteria, demethylation
Same.
happens
Same.
inside.
In the membrane also. Yeah, yeah. Okay. I said it's tricky. Takes longer to methylate than to demethylate. Remember, methylation occurs with an attractant. Demethylation occurs with a repellent. The reason this occurs is because transferase with an attractant is a slow enzyme. Esterase with the repellent is a fast enzyme. See, enzymes are different just like people are. And we can have fast and slow enzymes just like we have fast and slow people. This actually answers my complaint earlier. I was commenting that it doesn't seem to make sense that a bacteria would respond longer to an attractant than to a repellent. Well, this is the reason why. Because methylation is occurring with an attractant. And it's a slow process. That's why the bacteria responds for a long time. because it's slow. Demethylation with the repellent is a fast process. The enzyme is fast. So it doesn't take very long to demethylate. That's why it doesn't respond very long. It still doesn't make any sense. You know, why would it develop that way? But it did. So that's the reason. Okay. Let's put everything together. You still don't really know where I'm going. And she asked a very good question that I didn't want to answer yet.